Hello everyone, welcome back to our generative AI series. In our last video, we looked at how RAG solves the problem of LLM hallucinations by acting like an open book exams. So what we'll be doing in open book exam is we'll have one or two books and we know the question paper, and according to that question we'll be going and searching to the books, and when we'll get the answers we'll be putting that into the notebook. So same here, that AI is allowed to search the references material before writing that answers to or answers or the output. Okay, but we can't just pass a 100 pages of PDFs or any documents directly to an LLM every time, because when we'll be asking some question regarding that PDF or document, we have to put that document to the LLM or with our user query. Okay, so it will make that LLM very slow, and it is also a waste of tokens, and it will break the context limits. So actually build a production RAG system, we need some specific tools or components. So in this video we are going to understand these components, what we need to configure. So we have 8 or 9 components or building blocks of the RAGs. So we'll be going one by one. So first is knowledge base and data sources. So for knowledge base, it means we have to store domain specific or general information like documents, APIs or DB. We have to gather all these information which we need for our app, and we have to store that data into the knowledge base. And for example, we have HR policy documents, resume dataset, medical documents, and other documents. Whatever we needed, we have to store that into the knowledge base. So that's what it mentioned here. External information sources, example PDFs, docs, websites, databases, or any APIs. Then the second component is chunking and pre-processing. So this is a text chunking and pre-processing. So here what we are doing is this is a process of breaking down the large data into the smaller or manageable pieces that we called as a chunks. Suppose if we have 100 pages of data, it will be so difficult to understand it for the models. So making them into a smaller chunks, it will be easy to understand for the models as well. Okay, so we'll be dividing that particular uh, PDF or particular document into the smallest chunks. Okay, so if we'll see the example, we have this document. Okay, so this is a huge document. If we'll see here, uh, it's around 29 pages. Every time if we want to know something about this private car long-term package policy of the SBI, it will be, we have to paste every time this PDF, and then LLM models will go and read all the context whatever it is here. But we just need to know about the all type of vehicle, this no claim bonus details. So it's very difficult and it is a tedious task. It's going for the huge document and then we'll be getting the outputs. So in place of that, here we'll be dividing this data into the smaller chunks. So for example, if we'll see here, we can divide this definition into the one chunk, or it depends how which method we are going to use here to divide that chunks. Okay, so in high level I'm just saying, for the definition we'll make it as a one chunk, and then for accidental loss or damage to the vehicle, we can vehicle insure, we can make this into the one chunk. So like this we can divide our PDFs or documents into the smaller chunks. Okay, yeah, so now we can divide that data into the chunks. Now why chunking is needed here? Because LLMs cannot efficiently process this huge document at once. So if we'll give that to the if we'll provide that smaller chunks, it will improve the retrieval accuracy for the LLMs. Okay, and each chunk will just focus on the specific topic. That's what I mentioned in the PDF when I showed. So it will just mention to the specific topics. When we'll get that data from the source data set, we can apply that data to the user query. Now we got this chunking is done, and now we'll have that data, then we can apply that to the user's query. And here in the PDF we'll have maybe some unnecessary symbols or data, right? We have to clean that data over there. So we'll go to the third component, that is embedding models. So what embedding models will do is, now the source data is already broken into the smaller chunks with the help of this component, chunking and pre-processing component. We already divided that data into the smaller chunks, but still that data is a text. That models will not understand that text, right? As we discussed this on the LLM video. So that is still, that data is a text, so we have to convert that data into the vectors. So when we'll be converting text into the vector, that will capture the semantic meaning behind that text. For example, we have car and vehicle. Okay, so both will, what will have happen is, both will have similar vector representation because they are semantically related. As a human, when we'll see, okay, car or vehicle, we can differentiate it. Okay, so if it will just match, okay, that vector, okay, this is a similar words, car and vehicle, it will be difficult to understand that meanings, what is the meaning behind that sentence, right? So instead of matching exact words, it will also match the meanings over there. So this will allow the semantic search. And document embedding will allow the systems to understand the user's queries and match them with the relevant informations in the source data set based on the meaning of the text, or instead of comparing text, it will go for the meaning of the text. So this is for the embedding model. If you'll see here, it mentioned, right, convert text chunk and queries into a vector representation. Here we are going to make it in the vector representation. Then we'll have vector database. This is the fourth component. So what it will do is, here we did embedding, right? So it will store embedding and enable fast similarity search. So what will happen is, we have that, we converted that text into the vector, and now this vector DB will store all the embedding efficiently, and the vector database perform here the similarity search to find the closest matching chunks. What are the closest matching chunks will be there, it will just figure it out, that chunk. For example, we have different vector DBs like as Pinecone, Viviat, Chroma, etc. Okay, and now we'll go for the query encoder. So when user will ask a questions, okay, that is the query. Whatever we are going to ask to these models, that is the query, and the query is also converted into the embedding vector. Whatever the embedding model we used for the PDF conversion, same we will be using for the query conversion as well. Okay, so for example, what is the leave policy? Okay, this is a query, and this query we have to convert into the vector, so it will be converting to the vector, and this vector is compared against the whatever the stored documents vectors are there, on against them it will compare that the query. Okay, so this is for the query encoder. And if you'll see here, it's also mentioned it convert user's query into embeddings, same vector space as documents. Then retriever, what retriever will do, this is again a component. So what retriever will do, it will searches the vector DB and figure it out the most relevant chunks based on the vector similarities here. What are the vector, just we mentioned, right, car and vehicle, so it will go and check what are the vector similarities over there and what are their meanings, semantic meanings will be there. According to that, it will go and retrieve or fetch our data. If we'll be asking for the leave policy, so it may be retrieve leave policy section, sick leave rules, paid leaves documents, or instead of, because for the company there is a huge pages on a PDF for the leave policy or for any policy, right? So in place of it will go and search for all the details, it's better it will go for a separate chunk here. So what it will retrieve is leave policy section, sick leave rules or paid leave documents. So instead of retrieving all the pages in the documents, it will retrieve few sections over here. So this is what the retriever. So it will fetches top k relevant chunks from the vector db. It will not go and fetch everything, it will just top k, maybe 2 3, which is the most relevant chunks will be there, it will go and retrieve that data. Then augmentation and or prompt builder. Okay, so what it will do is this augmentation layer, it will combine the retrieved chunk, whatever data we retrieved right from the retriever part, that will take that retriever chunk with the user query, whatever the query we posted, it will go and augment these both the queries, and it will provide that context to the LLM. So now LLM will not have full PDF, it have just small chunks, maybe 2 or 3 chunks plus our query. So it will not go to read all full documents whatever we provided. Okay, so here context means whatever the policies we retrieve, policy chunks we retrieved, that is the context, and questions, whatever the user query is there, these two things will be augmenting it and giving to the LLM models. So combine retrieve context with the user query to build the final prompt. Then LLM generator. So LLM generator, the final response. Okay, it will go and generate the final responses for us. It will use that query, and what are the retrieved knowledge is there from the knowledge base, it will use that content and it will generate the responses for us. And now this time this will produce a more grounded and reliable answer, because it knows, okay, these are the 3 or 4 policies on there, on these 2 or 3 policies I have to figure it out what is the exact output. It don't have the full PDFs to understand it. Okay, then if we'll see here, it's like generate the final answer using the augmented prompt, then updater or indexer. This is the optional one, but still if we'll not perform this, our RAG is also behind. Okay, so regularly refreshes and re-embeds data to keep the knowledge base up to date. So our knowledge base will be up to date here. Example, we have to add the new document or we have to remove the old documents. Okay, so we have to make sure that our knowledge base will be up to date. Now this is the PDF link which I showed. So for example, if we'll be asking what is my mother name, okay, so chat GPT or model, they are not aware about what is my mother name, so they'll mention I don't have any way to know your mother's name, but I am happy to help with any questions you have about names of family or family history. Okay, so for this what we need to do is we have to, for solving this we have to provide the external data, in this case our mother information we have to provide to that model, then they'll be get to know that okay, what is my mother name. Okay, so what we'll do is we'll have this user. Okay, user means I am asking what is my mother name. So I am a user and I am asking a question to the chatbot or language model, and then it will query the knowledge source or retriever model. So here I saved my mother name, so it knows okay what is my mother name, and it will go here and it will retrieve that data, and now it has the knowledge of that name, and it will send to the language model. So now language model, according to what is the data it retrieved from here, it will go and just process our query plus this name and we'll get the response back. Okay, so here the retrieval model, what it will do is it will fetches the relevant information from the external sources, just like as database, search engine or other information sources, and the language model, they'll generate a responses based on the retrieve information. Now okay, so except that we have this questions when we'll go this part, this concepts, right? So how is RAG configured? So that it can fetch data from Google, documents, or other external companies' data. So RAG does not automatically know where to fetch all these data. For that, we need to configure and build the data ingestion pipelines ourselves, so it will be aware, okay, how, in which document it will go, or in which knowledge base it will go and fetch the content. And the second question is, in RAG we are also storing documents, URLs, or other data in a database. If the database is not up to date, we'll still get old data. Then how is it better than an LLM? So still RAG is better than the LM, because its knowledge is stored externally and can be updated by simply modifying the documents or databases without retraining the model. And if the RAG database is outdated, suppose if we didn't put that data into the RAG system or in the knowledge base, so that is the outdated data. It can still know about that old information, okay? But if we are going to update that external data, it is much easier than or faster than as compared to training the models. Then third one is, when retrieving data from the knowledge base, do we get only one document or multiple relevant results? So the retriever performs here the similarity search and return the top k most relevant result. That's what we discussed, right? It will return as the top k most relevant result. For example, top 3, top 5, or top 10 chunks it will return us based on the user's query. So whatever the users, what are the query we have, according to that we'll get the 3, 5, or 10 chunks here, okay? And these whatever the chunks we retrieve, these chunks are then combined and sent to the LLMs for the context for generating the final result. And then our images, video, audio are considered as unstructured data. Yes, images, audios, and videos are generally considered as the unstructured data because they are not followed any tabular or schema based formats, just like as rows and columns. That's why we are treating them as a unstructured data. So till now we got to know about that components and the working of the RAG. And so we just need to combine these things and how it will be working, okay? So it means we'll go and know about the architecture. So how we can combine these components, we'll see in the next video.